welcome to my channel. So in this video I am going to explain the important concept of that is difference between microprocessor and microcontroller. Okay, so let us discuss what is actually the microprocessor definition. Okay, so microprocessor is a multi-purpose programmable logic device. So it is a multi-purpose programmable logic device made up of what? Silicon chip by using VLSI technology that reads instruction from a storage device either RAM or ROM or IO devices accepts binary data as an input and process according to those instructions and provides result as output. So this is the basic definition of microprocessor. So what it will do? So it is a multi-purpose programmable device. It reads the instruction from any storage device, either it is the RAM or ROM or input devices, and encode that data, okay, that is binary data, okay, binary data as input, and process them according to those instructions and provides as a output. So this is the basic definition of microprocessor and microcontroller. Okay, so here what is the main difference between microprocessor and microcontroller? See, I am going to explain with one small example. So here both in the microprocessor and microcontrollers. For example, here CPU is there, so and also input. Okay, input in it is there and output in it is there in a system. So system, basic system. So here the memory. Okay, so memory also there, memory and peripheral devices actually. So peripheral device, the peripheral inputs maybe in timer. Okay, so for example peripheral. Okay, so peripherals. Okay, peripherals may be either a timer, okay, timer or ADC channels or IO channels. Okay, all these are what? Externally connected to CPU. So this is the main difference. Okay, so this is what CPU. Here CPU is what? Microprocessor. The basic difference I'm going to explain the microprocessor and microcontroller, how the chip look like, right? So here the CPU is there. For this CPU, all these devices, this memory, that is memory, IO, that is IO, inputs, that is input and output units, and peripheral devices, all are connected externally to your CPU. Okay, there is no inbuilt memory is available for available in microprocessor. Okay, this is what in case of microprocessor based system, right? What about microcontroller system? So microcontroller also as CPU. Okay, as CPU. Then it has what? IO devices. Okay, it is going to connect what? IO, and then what? Memory. Okay, so memory, and then what? Again. So here it is peripherals. Okay, so peripherals, that is inbuilt. Peripherals. Okay, peripheral, that is like timer. Example, timer, ADC. Okay, all these are there inside this CPU itself. So the whole thing is what? All this contains what? Inside the CPU. This is what? Microcontroller. See, so here in this microprocessor system, this the input device, that is inbuilt, it does not contain any inbuilt memory and also inbuilt peripherals. Okay, inbuilt peripherals are not not available in the microprocessor, as well as inbuilt memory also not available in case of what? Microprocessor. But in case of microcontroller, it has IO ports, memory, okay, memory, peripheral device, all are inbuilt in a single chip. In a single chip itself, it is there available in what? Microcontroller. This is what main difference between microprocessor and microcontroller. Okay, so what are the other differences? Basically, this microprocessor is used for what? General purpose digital computers. So it is used for what? General purpose. Okay, general purpose digital computers. General purpose digital computers. Okay, but microcontroller so mainly used for what? Special purpose digital computers. It is used for what? Special purpose digital computers. Okay, digital computers. Because here the in memory, so inbuilt memory is what? Only limited capacity, so it can perform only dedicated task functions. That's why, okay, most probably in many embedded systems they are going to use for doing this particular task or specific task, they are going to use the CPU as what microcontroller rather than microprocessor. You can use microprocessor also, but it used for what? General purpose digital computers. Okay, so it does not contain any inbuilt memory and inbuilt peripherals. Similarly, in this microcontroller, all it contains what? Both inbuilt memory as well as peripheral devices like timers or counters or ADC channels or input output ports. Everything is there in the chip itself. So you can connect the directly. You can connect the input ports and peripheral. You can use the peripherals over here in case of what? Microcontroller. Okay. So this the and also so while all the components are there in the what controller itself for small application purposes. So which one is better? So when compared to microprocessor, microcontroller is more than more efficient because it is a faster. Okay, far faster for what? For small applications. Okay, so it is what? Slower because all are externally connected to your CPU. Okay, so that's why it is what? Slower. For example, I am going to give one small example for this one. So for example, you just consider it in your room. Okay, so for example, if you want to drink some water, okay, so if you want to drink some water means what? You have to go for some other location. Okay, you have to go for example, in your from your room to what kitchen, or for example, if your room to some dining area, wherever the water resources is available. So we have to go for water. That resource area, and you have to consume that water. After that, you have to return back to your room. So that is what in case of microprocessor. So you just assume the microcontroller. For example, in the room itself, in your room itself, you are having what? One water ductor. Okay, water ductor, or one filter is there in your water filter is there in your room itself. Okay, so it is easy to consume. It is easy to consume in the room itself. So the time consuming is what? So very less when compared to a microprocessor, okay, rather than microcontroller. That's why. So here you just assume, for example, this is here inside this room. You just assume this as one room, and here this is what? Outside room. For example, this, okay, this block contains what? Water. You just assume the water. Okay, so here the inside the room itself water is there, so you can access the data as faster in case of what? Microcontroller. But here just see this block, this IO block, you just assume as this water. So water content, right? So if you want to access the this water content, the CPU have to communicate what? Outside one. Have to communicate what? Outside one. So it will take more time to do that operation. Okay, so that's why. So when compared to small applications and all, so microcontroller is more than enough for microcontroller is more efficient than microprocessor. And also whatever is size also very compact, because all these components are inbuilt in this microcontroller. But here all these components are externally you are connecting. So if you are externally connecting, was the system size is more in case of what? Microprocessor based system. The system size. For example, if you want to perform one application, if you want to design one application in based on microprocessor based system. So in here microprocessor based system means what? You need memory, IO device, everything is connected in what? External to your CPU. So it will take more space, and also power consumption also more, because you have to activate all those components, right? That is in case of microprocessor based system. But in case of microcontroller based system, everything is available in the chip itself. So only the operating voltage is given for only chip for accessing all those functionalities. Okay, so that's why. So this is what the compact size in case of what? Microcontroller based systems. Okay, so these are some of the main differences between microprocessor and microcontroller. Okay, I hope you understood now the main difference between microprocessor and microcontroller. Okay, so please share, subscribe and like this video. Thank you.